What's up, folks? Friends of C461, or wherever you are from the internet. Today, I'd like to walk you through solving this problem of level pool routing. I think, first of all, before I do so, I think messing around is a good thing. You just apply what you've learned in class and mess around, make mistakes, and correct the mistakes is a very valuable thing. So I won't take that away from you. However, in the class, it was not possible to give all the details. So I'd like to do a bit more details here, okay? To kind of show you a few steps. How did we get these numbers? How do we get these numbers? Okay, I demonstrate the steps which we will need to carry out the calculations to arrive at this discharge estimate. Okay, I've reformatted the piece of paper so it looks a little bit different from what you've got. I'm going to demonstrate this by hand because I want you to know the processes, because of course you can do this in Excel. Okay, so the level pool routing really is composed of three parts. One is an equation. Second is a lookup or interpolation. Third, it's a trick. Okay, as a trick to make the calculations a bit easier. So first of all, let's start with the equation. The equation results from a finite difference approximation to the continuity equation, okay, which looks like this. And you've seen me doing this in class. I'm just going to briefly do it again here and go right into the calculation details. So if we rearrange this equation, we get Sn plus 1 over delta t plus qn plus 1 is equal to in plus im plus 1 plus 2Sn over delta t minus qn. Okay, so the essence of this equation is that it arranged all the knowns on the right-hand side, okay, I call right-hand side, and all the unknowns to the left-hand side. Okay, we have to apply this equation in order to proceed in solving this problem, and this is also why you see the headings of the calculation table are provided this way. So step one is to calculate the things on the right-hand side and apply this continuity equation to get us the right-hand side. And step two is to take this value and look up in order to get discharge Q. Okay? Step three is to take these two values and get us, doing the trick to get us 2Sn delta t over Qn for the next step. All right? Okay, so let's move on with the step one. Okay, step one, you see these components are what's listed in this table. These two components, let's call this column A, let's call this column B, call this column C, call this column D. Okay, so essentially we have column A here and column B here. All right, these things are what we have already. We take column A, which for the first step is essentially I of 1 plus I of 0. Okay, that gives us 10, and that's why you see this value 10 here. Okay, initially S is 0 and Q is also 0. Okay, therefore column B for this time step, 2s over delta t minus q is also is 0. Okay, and then if we add up the two, A plus B, that gives us the content in column C, which is basically this procedure here. Okay, this procedure here. Okay, and you get 10 also. Now here comes the tricky part. How do we take this value and do the interpolation? Some people or folks are kind of confused how you go this step. Okay, in order to do that, we're going to have to build a relationship between 2s over delta t plus q and discharge. However, originally what the data that was provided to you is s to discharge. Therefore, we have to go do this step ourselves. 2s over delta t plus q. Okay? So we have to construct this table ourselves. For this first guy is simply 0. For the second data point, you take 32670 divided by the time step, which is 10 minutes, and you convert that to seconds, that's 600 seconds. And then what we get out of here is 112. Okay? For the second table, you take this value, divided by 600, and then you plus the 8. Okay? Then you get 225. For the third value, similarly, you take this value divided by 600 and plus 17, you get 343. Okay? You can proceed and fill in the entire table. So we need that. So now we take the 10 and we want to do the interpolation. And the interpolation goes, you take the 10, okay, because 10 is somewhere between here. So we use these two data points to do the interpolation, and we can just do a simple linear interpolation. Okay, so we take 10 minus this point, 0, and that is over a cross of a step of 112 minus 0. This value just gives you the fraction of how big of a step this is. That is corresponding to 3 minus 0 in the y, in discharge. Okay, in the y. And that plus the 0, and you do the calculation, it gives you 0.27. That's where this values come from. Okay, now here comes the third step. Okay, the third step. So this is the second step, lookup table. Okay? Third step is what I said, the trick. So we take this value 2Sn plus 1 over delta t plus q, okay, which is 10 in this case. We minus 2 times 0.27. Does that not give us 2s plus 1 over delta t minus q? That's really give us this value. Oh, I might have skipped a few seconds of writing here. I missed that. But basically, this is the trick, okay? 2s over delta t plus q minus 2q, that just straight gives us 2sn plus 1 over delta t minus q, right? However, for the next step, this guy has been downgraded. When we go to the next step, n plus 1 becomes n, and we get 2sn over delta t minus qn, which is what we need in the next step here, okay? So this is the trick. We can directly go from this guy to this guy in the next step without going through all the loops. This is the trick I was talking about. Okay, so you take 10 minus 2 of this, and you get 9.46. Okay, so let me do this for one more step. In the next step, you take these two values. Okay, you take these two values, you get 30 plus this guy, you get 39.46, right? 39.46, and you go across the bridge from a plus b equals to c through the continuity equation, okay? Through the continuity equation. This is column C. Through the continuity equation. So you get 39.46 here. Then, when we are about to do this interpolation, we go 39.46 minus, because we're still inside this interval, okay? We're still inside this interval between 0 and 112. So we take 39.46 minus 0 and 112 minus 0 times 3 minus 0 okay, plus 0. And if we do the calculation, that gives us 1.06. Okay, so that's where that value is from. This is linear interpolation. This is where this number is from. And this is linear interpolation, and you can do it graphically, but doing this linear interpolation is probably better, more accurate. Okay, and let me demonstrate one more step. If you just proceed this way until this step, okay, until you got a 4.79 here, you got a 4.79 here. All right, I'd like to show you how you get 4.79 from 152, because previously this end was all 0. This was all within the first bin. Now, when our value is 152, we're in the second bin. Okay, we're in the second bin. It goes from 112 to 225, and the y value goes, the discharge goes from 3 to 8. Okay, so if we take 152 minus the lower end 112 over 225 minus 112 times 8 minus 3 in the Q plus the starting point of Q, do the calculation, you get 4.79. Okay, so that's why I want to show you what do you do when you move to the next step. Believe it or not, you can do this in Excel as well. Okay, you can do this linear interpolation in Excel. You have to be a bit more careful. All right, guys, this is actually the first time ever I'm doing a YouTube video on how to solve a homework. Is it too slow? Does it make sense? Is it too detailed? Please let me know. Okay, I hope this helps you with your homework.